Namaste doston. Namaste doston once again. Now we have come to the part 6 of our collaborative PM system with the ASP.NET Core, and in this part we will be configuring the entity framework code DbContext within the infrastructure project. So switch over to the slides and then to the Visual Studio demo. We'll wire it up based on our actual domain model, which includes project, task item, user, team, comment, attachment. Okay, so let's see what we are up to. The first step is the role of DbContext, now which is a bridge between the domain entities and the database, and which tracks changes, saving updates, and managing relationships. So next we'll see what are the steps involved in this process in today's lecture. And after that, I will just go through this Visual Studio Code straight away for a complete practical demo, keeping the rest of the theory after these 4 steps are implemented in Visual Studio Code. So I expect you to please go through the entire video. Don't leave it in between to get the maximum value out of all the labor that I have done for you for making this a successful. After that, we will go through the theory. So over to the Visual Studio demo code. So here is our application DbContext, the class that connects our domain to the database. Think of it as a single conversation with a database. It tracks our entities, translates LINQ into SQL, and saves changes. Each dbset or generic T you see here represents a table. For example, dbset projects is the gateway to the projects table. dbset task item maps to task items, and so on for users, teams, comments, and attachments. The setT method simply tells the context to hand us the collection for that entity so that we can query it or add new rows. The real power is in onModel creating method, where we configure our mappings with the Fluent API. For project, we set the primary key, make name required with a maximum length of 200 and description optional with up to 1000 characters. Then we define relationships. A project has many tasks and many teams. Each task and team carries the foreign key, project ID, and we enable cascade delete, so removing a project removes its children automatically. For task item, the title and status fields are required. Each task can have many comments, again with cascade delete, so the related comments are cleaned up if a task is deleted. Users are simple here. We enforce required username and email with sensible maximum lengths. Teams are interesting. Each team has a required name and can have many members with many. We define a many-to-many between teams and users, and Entity Framework Core automatically builds a join table behind the scenes. For comment, we require content and created at and limit the content length to 2000 characters. For attachment, both file name and file path are required with maximum lengths set to keep the schema clean. So to summarize, DbContext gives us the entry points through dbsets, and onModel creating is where we look down rules and relationships. One-to-many for projects to tasks and teams, one-to-many for tasks to comments, and many-to-many for teams and users, and sensible constraints for comments and attachments. That completes our database mapping and gets us ready to run migrations. Next, we registered our DbContext in the infrastructure layer using an add infrastructure extension method. Here we configured it with the use SQL server, which reads the default connection string from appsettings.json, which is to be created in the next step. Now this allows our application to connect directly to the SQL Server database. After that, we needed to fix a compile error because use SQL Server wasn't recognized. The issue was that the SQL Server provider package was missing And to resolve it, we added the package from the CLI at the solution root with this one-liner .NET add CollabPM system infrastructure package Microsoft.Entity Framework Core.SQL Server. Once installed, I quickly opened the NuGet package manager to confirm that Microsoft.Entity Framework Core.SQL Server appeared in the infrastructure project. With that verified, the error disappeared. The DbContext compiled successfully and our setup was complete and ready for migrations in the next stage. Okay. Now here we are building the project after the completion of the last two steps. As you can see, it compiles cleanly. Now the next step is to configure our connection string. We do this inside the API project because that's the startup project of our solution. In the appsettings.json file which you have just opened, under the connection strings, I have added an entry called default connection. It points to SQL Server on localhost, creates a database called CollabPM DB, uses Windows authentication with trusted connections, and allows multiple active result sets and trusts the server certificate. This is all we need to do at this stage to let Entity Framework Core connect to SQL Server and prepare for our migrations. Okay. Now that the connection string is in place, the next step is to register our infrastructure layer inside the Program.cs file right after creating the builder. We call builder.services.add-infrastructure builder.configuration. This ensures that our application DbContext is wired up with dependency injection and ready to use throughout the project. With that added, I will go ahead and build the solution again. And as you can see, the build succeeds without any errors, which means our DbContext and infrastructure setup are now fully integrated and ready for migrations. Now let me show what fluent API relationships we have created through the application DbContext. Now we have got this project to tasks and teams. This is one-to-many relationship between project to task and project to teams with a cascade delete. So if the project is deleted, so all that related tasks and teams will be deleted. Similarly, we have got one-to-many relationship between task items and comments, and there is a cascade delete. So any task item that is deleted, all the comments will be deleted. So there will be no orphan comment. And then team is to user and user is to team is a many-to-many relationship. So finally, this is the entity relationship diagram also. This is project to task item one-to-many and project to team one-to-many and team to user many-to-many, user to team many-to-many, team to attachment one-to-many, okay, task item to comment one-to-many relationship. So coming to the summary, we have our DbContext created and registered, entities mapped with Fluent API, connected to SQL Server, now ready for migrations in the next lecture. So thank you very much, and if you like this, please subscribe to the channel and share it with your friends.